Hello everyone. Today we are going to study the heat equation and a specific heat capacity. Let us see, there are two cases. Suppose this body is of 4 kg and this body is of 10 kg. Both are at same temperature and we are heating this body to the 25 degree Celsius. We are heating both the body to the similar temperature and we are creating the similar temperature difference, 5 degrees Celsius difference, 5 degrees Celsius difference.
Both body are
Then
made up
does
of same
this
material.
both body require the same amount of heat? No, this body is of higher mass, this require more heat to have the similar temperature difference. This is the less mass, this body require less heat. Okay, then we can say heat is directly proportional to the mass of the body. Heat gained is directly proportional to the mass of the body. In the second case, we see here both bodies are of same mass. This is a 20 degree Celsius, this is also a 20 degree Celsius, but we are heating this body to the 25 degree Celsius and this body to the 75 degree Celsius. Does they both take similar amount of heat? No, because this has very less temperature difference. If we give less heat to this body, it can easily go here, but this temperature difference is very high, so we require to heat this body to a greater amount. We have to supply more heat to this body so that its temperature can go to the 75 degree Celsius. What we see there, temperature difference less, then less heat should be given here. Temperature difference is more here, then we have to supply here more heat. So we can say that heat is directly proportional to the change in temperature. This dt represents difference in temperature. Larger the temperature difference, larger will be the amount of heat required. Okay, and this is equation 2. Combining equation 1 and 2, combining equation 1 and 2, we get H is directly proportional to m dt. Okay, then when we remove this proportional sign, what will be? H is equal to S m dt, and this S is called proportionality constant. This S is proportionality constant, and this is also known as a specific heat capacity. A specific heat capacity. Okay, now this equation can also be written like this: H is equal to ms dt, and this equation is called heat equation. This equation is called H is equal to ms dt. This is called heat equation, and that this H can be also regarded as amount of heat gained or amount of heat lost. M is the mass of the body, S is the specific heat capacity of the body, and dt is the temperature. Heat equation we can write this S is equal to. Now let us define a specific heat capacity. Suppose we say S is equal to H, then in which condition we can say S is equal to H? If mass of the body is 1 kg and change in temperature of the body is 1 degree Celsius, then at this condition we can say S value will be equal to H. Then let us define here. S is the amount of heat required by the 1 kg body to increase its temperature by 1 degree Celsius. S is defined by, now here we can define the specific heat capacity. A specific heat capacity is the amount of heat gained or heat lost by 1 kg body to change its temperature by 1 degree Celsius. And what will be the unit of this specific heat capacity? Let us see. The unit of H will be joule, mass will be kg, and temperature unit will be degree Celsius. So the unit of specific heat capacity becomes joule per kg degree Celsius. Let us practically understand now. The different substances have different specific heat capacity. Now let us practically understand the specific heat capacity. Suppose any substance A have a specific heat capacity of 400 joule per kg degree Celsius. Then what does this mean? Let us understand. It means that for 1 kg body, when we take 1 kg a body, suppose it is a temperature of 20 degrees Celsius, then if we supply 400 joule of heat to this body, its temperature will increase by 1 degree Celsius. It becomes 21 degree Celsius. How much is the specific heat capacity? That much joule of heat energy if we give for 1 kg that body, then its temperature will increase by 1 degree Celsius. Or if we remove 400 joule of heat energy from that 1 kg body, then its temperature will decrease by 1 degree Celsius. Suppose it is at 20 degree Celsius. If we remove 400 joule of heat energy from it, then its temperature will be 19 degree Celsius. I hope you are understanding this. The value of a specific heat capacity is the amount of heat that is given to the body or taken out from the body for 1 kg to change its temperature by 1 degree Celsius. Water has the highest specific heat capacity in this planet. The water has the specific heat capacity of 4200 joule per kg degree Celsius. Let us understand practically what does this mean. It means 1 kg water, if we increase its temperature by 1 degree Celsius, we have to supply here 4200 joule of heat energy. Suppose the water is at 20 degree Celsius, we have to make it 21 degree Celsius, then we have to supply 4200 joule of heat energy. Suppose we have to make it 22 degree Celsius, again we have to supply 4200 joule of heat energy. Again, if we have to increase 1 degree more Celsius, again if we have to increase the temperature to 23 degree Celsius, again we have to supply 4200 joule of heat energy. Okay. The substance that have high specific heat capacity, they heated slowly and they are cooled slowly. This is the fact about the specific heat capacity. The substance that have very high specific heat capacity, they are heated slowly and they are cooled slowly. Since the water has very highest specific heat capacity, it does not get heated very fast. Suppose we have to heat the water, we have to supply more amount of heat, then only it can be heated. But this substance, if we supply 400 joule of heat energy, then they increase by 1 degree Celsius. But if water has to be heated by 1 degree Celsius, we have to supply 4200 joule of heat energy. Water get heated very slowly. Once the water gains the temperature, highest temperature, they do not cool down fast. Because if we have to cool from 23 to 22 degrees Celsius, we have to remove 4200 joule of heat energy. But if we have to change this substance from suppose 20 to 19 degrees Celsius, if we have to decrease this temperature by 1 degree Celsius, we have to remove only 400 joule of heat energy. But if we have to decrease the temperature of water, we have to remove 4200 joule of heat energy. So what we see here, if we have to heat the water do not get heated fast because it absorbs large amount of heat energy, then only its temperature is increasing. But other substances which have very less specific heat capacity, their temperature rises very fast because in a small amount of heat energy they are gaining, their temperature is increasing by 1 degree Celsius. So water is used to cool the hot engine. Because water has highest specific heat capacity, it absorbs large amount of heat for a small rise in temperature. But instead of water, if we are using any other substance that has less specific heat capacity, they will absorb the heat, but temperature will rise very fast. The substance, that liquid will also become more heated. But when we use water, it becomes less heated, but it decreases the water becomes if we use water becomes less heated, but it absorbs more amount of heat from the engine. I hope you understood this topic, a specific heat capacity.